So we have to show that the point of inflection on this curve all lie in a straight line. So let's first find the first derivative. We need to find the second derivative, so let's find the first derivative, and we get -1 minus k minus x. Differentiate the bottom, you get 2x all over squared. Okay, gotta clean that up. You get this, right? So we get x squared minus 2kx minus k squared on top. Okay, so I put in the general form, the quadratic general form. Okay, one more time. So you get 2x minus 2k minus x squared minus 2kx minus k squared 2x squared plus k squared times by 2x. Alright. So let's reduce right away what we can. It's this. That'll become 1 and that'll become 3. Okay, and the top will become 2x minus 2k x squared plus k squared. This is 4x. Okay. Alright, we need to expand that. Expand this now. Okay, so collect the like terms, and what do we have here? That's, those two are same. Okay, which one has just k squared and x? There's k squared x here, and there's a k and x squared here, so we actually get a 10 k squared x, and then kx squared, there's one here and one here, so that's plus 2 kx squared, and then only 1 to kx cubed. So I think I made a mistake. You gotta add these two, right? So it's 6. And I gotta add these two, so you get 6 also. Okay, so to find the inflection points, we need to set this equal to 0. Now, there's no way, it's 0 actually or undefined, but there's no way this can be 0. Everybody knows why, right? Well, it can't be 0 assuming k is not 0. If k was equal to 0, then we can set x equal to 0 and it'll become undefined. Okay, but I think we can assume for this question that k is some positive or negative constant. Okay. Okay, so that means we need to solve for x using the top equation. Okay, so look at the coefficients of the top. Minus 2, 6, 6, minus 2. Okay. Alright, so I think if you plug in minus k, it'll work. If you plug in minus k, you get minus 2 minus k cubed. This will become positive 2k cubed, right? So it'll cancel out with the one at the back. And these two will have opposite sign. Okay, so let's do synthetic division with minus k. So it's minus 2 minus 6k squared, 6k, and minus 2k cubed. Those are the coefficients. So 2k. Let's add that.
Why is it minus?
Sorry, my bad. It's positive, so it's positive here. And then multiply by k again, you get 6k cubed plus 2k 2k squared. Both minus, right? Okay, so this is not working because I messed up the coefficients. This is power of 2, this is power of 1. Okay, so 6k and 6k squared. Okay, it should be like that. So now it's 2k, so continuing on, you get minus 2k squared and you get positive 2k cubed, so it gives you 0. So that means this thing at the top would factor like this: x plus k by factor theorem minus 2x squared plus 8kx and minus 2k squared. Okay, so let's factor out minus 2, and you get x squared minus 4kx plus k squared. Okay, so definitely k is equal to negative, so x equals to negative k. X equals to negative k is one solution. We're going to get two more solutions from here, right? So we can use the quadratic formula. Minus b, so it gives you 4k plus minus b squared. So that's 4k squared minus 4ac all over 2a. Okay, so you get 4k plus minus, that's 16k. 16 minus 4 is 12k squared. So we can factor out 2, right? And get 3k squared. We can actually factor out 3k. So I mean, we can factor out 4k squared to get 2k. So the other two values are 4k plus 2k root 3 over 2, which actually gives you just 2 and 1 here, or 2k minus k root 3. And you have to show that these three lie all on a straight line. Is that true? So these are just the x values. We actually need to plug these values into the original function, okay? Okay, so let's plug it in here. When you plug in negative k, negative k, so if you plug it in, you get this: 2k over 2k squared. So that gives you 1 over k. Okay, let's plug in now 2k plus k root 3. So you get k minus 2k minus k root 3 all over 2k plus k root 3 squared plus k squared. So that gives you a minus k root 3. A lot of k's here. From the bottom, I can actually factor out a k squared. If you factor out k squared, I get a 2 plus root 3 squared plus 1. So we can actually reduce the k's. So 1k at the bottom. So we get minus 1 minus root 3. And if you expand the bottom, you get 4 plus 3. That's 7. 8 plus 4 root 3. Right now what we have, one of the inflection point is minus k and 1 over k. The second inflection point is 2k plus k root 3 and minus 1 minus root 3 over 8 plus 4 root 3. I think I forgot the k there. K. Okay, so we have one more point to plug in, but what are we going to do after we plug in the one more point? To show that they're all on the same line? find slope, and the slope has to equal to each other, and then you're done. So if you plug this in, this is what we get for the y value. Okay. Let's call this point A. Let's call this point B, and let's call this third point C. Okay, where it's 2k minus k root 3 and minus 1 plus root 3 all over k 8 minus 4 root 3. So I did rise over run, and this is what I get. Okay, so I'm going to multiply top and bottom by k first, and the k from the top will disappear. And the bottom, this is 3k, so we get 3k squared plus k squared root 3. Okay, so this is what I get in the numerator if I add these two numbers on the top. Factor out the k squared and you get 3 plus root 3. Okay, so there we have a version of it. Now you have to find the slope between A and C, or B and C. Yeah, that's what you get for the slope expression. Okay, so we can cancel these two out. Okay, so that's the next step. So it simplifies to that. So the other one, right?
Where's the other
Right
one?
here? We actually need to multiply top and bottom by conjugate pair. Because
And would it give the same answer?
so we need to do this first of all.
어이구야.
8 minus 4 root 3, 8 minus 4 root 3, top and bottom, and 3 minus root 3, and 3 minus root 3. If you multiply these two, you get 64 minus 48 again. Okay, so multiplying these two gives you 9 minus 3. And then you need to multiply everything on top. So
Next question.
if you expand all of it, we get negative 1 over 4 k squared. So voila! Same straight line.